This is chapter 11 from the textbook, and this covers right angle triangles and working out sides and angles with right angle triangles. So the first thing we need to recognize is the labeling of the sides. This is going to help with the two types of things that we can do with right angle triangles. And I'm going to use this Greek letter here, theta, to represent the angle. Theta, it could be x, could be something different. And the side which is opposite the right angle, this one here, we always call the hypotenuse. Hypotenuse. Okay. Now, what's special about the hypotenuse is it's the longest side, and it's always opposite the right angle. And you can see it there. That blue arrow is pointing to the side opposite the right angle, which is the hypotenuse here. Okay, right, this side, which is, let's put an arrow, whoops, not that, put an arrow like this, so there's the hypotenuse. Okay, now over here, this side here, which is next to the angle, so that side is actually touching the angle, is what we call the adjacent, and adjacent just means next to, adjacent. So that's the side which is next to the angle. We call that the adjacent side. So I'll just put down here that this is next to the angle, next to the angle, and that just leaves this side here over here, and this is the opposite. We call that side the opposite because it is opposite the angle, so opposite to the angle, just like the hypotenuse is the one that's opposite to the hypotenuse. Right, so I'll just put that in here. Right, so we know the labeling of the sides. Now with right angle triangles, there's two things we're going to be able to, or we want to be able to calculate. So right angle triangles, RAT. So we're either going to be doing Pythagoras with right angle triangles, or we're going to be doing trigonometry with right angle triangles. I suppose you could say that Pythagoras is a form of trigonometry because trigonometry just means measuring triangles. But when I talk about trigonometry, I'm talking about this SOHCAHTOA business. So when do we use Pythagoras? Okay, this is for finding sides only. Finding sides only. Okay, no angles. So you have a question that has angles in it, you won't be using Pythagoras, you'll be using trigonometry. And trigonometry, this is for finding sides or angles, finding sides or angles. And in the question, you will have sides and angles, and or angles actually. So you may have sides and you're trying to find an angle. Okay, so let's start by looking at Pythagoras. So, got a right angle triangle. It may be drawn upside down, so just look out for that. Like this. And in a question to do with Pythagoras, we're either going to be finding the length of this side, which is the hypotenuse, or we're going to be finding the length of one of these shorter sides here. So this is going to be a shorter side, basically any side that's not the hypotenuse, or we're going to be finding the hypotenuse. So what we do, if you want to find the hypotenuse, you take the other two sides, you square the values of the other two sides. You add those values, so you square them first, then you add, and then whatever value you get, you square root. So we square first, we add second, we square root third to find the length of the hypotenuse. If you're finding the length of one of the shorter sides, you still start by squaring, but instead of adding, you subtract, and then we square root. So the only difference is the middle step. In finding the longer side of the hypotenuse, you add. In finding one of the shorter sides, you subtract. And obviously when you subtract, you want to do the larger value minus the smaller value, larger value minus smaller value. Yeah. Right, so let's do a couple of examples here. So let's say I've got a right angle triangle like this, and I want to find the length of this side, which I'll call x. This side is 11.2, and this side is 20.7, and I want to find the length of x. So there are no angles, so this is not, so could tell this is not trigonometry. So what do? Well, I'm going to square those numbers. So 20.7 squared, 11.2 squared. So let's write that down. So 20.7 squared is 428.49, and 11.2 squared is 125.44. 125.44. Okay, so we've done step number one, we squared. Step number two, because we're finding the hypotenuse, the longer side, we add. So it's very important we add. So I'll add those together. And that gives me 553.93. 553.93. And then the next thing I do is to square root. So I'm going to square root that answer. So third step, let's do it down here, is to square root that number. Now I can just, on my calculator, I can just do square root answer. So you could just press the answer button to get that last value up. And if I do that, I get 23.535717. It goes on for a few more digits. So to a suitable degree of accuracy, since the numbers are given to one decimal place, it makes sense to give the answer 23.5 to 1 dp. Yeah, you'll often be told in the question what that measurement is. So x here is 23.5, and whatever these units are, so I don't know, these might be meters here, so my final answer would be in meters. Okay, so that's an example where we find the longer side. Let's do an example where we're finding the shorter side. So let's say I've got something like this. So don't let the fact that this is turned around fool you or confuse you. So let's say that I need to find x here. This side is 10 and this side is 15. Okay, so same working as before, square. So 15 squared, 10 squared. So 10 squared is 100. 15 squared is 225. Don't know why I write 1,000, it's 100. Now this time we subtract. Now it doesn't make sense to do 100 minus 225. Can you get a negative number? So remember I said something about one before, you do the larger value minus the smaller value. That makes sense. So if I've squared, that was the first step. Second step, subtract, so that gives me 125. And then the last step is to square root 125. So let's do that, see what we get. So square root 125. It says 5 square root 5. Okay, so it's simplified it. I probably want a decimal answer, so I'll press my SD button and I'll get 11.1803 and so on. So maybe 11.2 And let's give this some units. So let's say these are all millimeters here. So I'll give my final answer 11.2 millimeters. So we've done an example finding the longer side and the shorter side. So we've basically gone through this part here. Now we can use Pythagoras in 3 dimensions. Now what's that going to be like? So let me attempt to draw a cuboid here, a 3-dimensional shape like this. So there's my cuboid. Let's put the edges in like this from the back. And in 3D, we're often asked to calculate the length of this diagonal here. Now that diagonal, it's difficult to see in this diagram, is going from the front corner to the opposite back corner. And in fact, when you draw something like that, it's the longest diagonal in that box. Yeah. So if you were trying to fit something in that box, that's the longest distance you can get. That longest diagonal goes from this front corner, yeah, at the top, to the opposite corner at the back, at the bottom. So it goes to complete opposite corners. Now, to do Pythagoras in 3D, it's very easy. So we just do one more number with Pythagoras. So if this was 7 centimeters here going across, if the height was 5 centimeters like that, and the depth, how far it goes back, was 3 centimeters like this, then to find the length of that longest diagonal, you basically just stick another number in Pythagoras. So that's going to be, you square the numbers, so 3 squared plus 5 squared plus 7 squared, so you still squared. So you square, add, square root. Now I've done it all in one calculation there. So that would be the square root of 9 plus 25 plus 49. So see, it looks like normal Pythagoras, but it's just 3 numbers. So let's add those up. 49 plus 25 plus 9 is 83. So this becomes the square root of 83. And if I work that out, press SD, I get 9.11. So let's call it 9.11 there. 9.11 centimeters. So basically, for any cuboid, if we called the lengths of the cuboid A, B, and C, it's basically this longest diagonal is the square root of A squared plus B squared plus C squared. So we're finding the longest side, like we are in triangles. So you just square, add square roots, but this time you just do it with 3 numbers instead of 2. Right, let's move on to trigonometry. So that's this bit here and this bit, but we might start with this bit here, angles of elevation, depression and bearings. So imagine that this is the edge of a cliff like this, and this is the sea down here, and there's a boat down here like this, and someone's standing on the edge of the cliff and they're looking down, and they're looking down, let's say, to the edge of the boat like that. Okay, you want to be able to measure that angle. So if we take this, like, which is like the horizontal, this angle here, that's called the angle of depression. The angle of depression. So this is a measurement from the horizontal going down. Okay, so we have this horizontal here, and we measure it from the horizontal going down. Horizontal. Okay, let's say different type of thing here, that there's a tree here. There's a fantastic drawing of a tree with green stuff at the top like that, and somebody is looking up. Say someone is lying on the floor and they're looking up at the top of the tree like this. Then this angle here from the horizontal again going up, this is called the angle of elevation. Angle of elevation. So we're either looking up or looking down from the horizontal. So in both cases, the angle is measured from a horizontal. It's either going down from the horizontal, or it's going up from the horizontal. Whereas a bearing is not measured from the horizontal, it's measured from the north. Now, we've done bearings already, the video on angles, so you can go back to that if you need to. So if I had some place over here, London, and I wanted the bearing from Manchester, then I would draw lines at the north like this and join them up, and this would be the bearing. Okay, that angle there, or the bearing that takes me from London to Manchester would be this one. Yeah, so bearings, we've done this already. Measured from the north, measured from north, which would be 0, 0, 0 degrees. So that tells us that they're measured in 3 figures. We use 3 digits for the bearing, and it's measured from the north in a clockwise direction. So you may be asked about angles of depression, elevation, or bearings where you're using trigonometry. So let's just remind ourselves about trigonometry. If you've got any trigonometry question, you always tackle it the same way. Okay, let's call this angle X. So step number 1, we need to label the triangle. Okay, so you're going to label it using H for hypotenuse, A for adjacent, O for opposite, HAL. You're going to, once you've labelled a triangle, cross out any useless sides. Okay, so any sides that are useless, they've got nothing written on them and they're no use, you cross them out. Once you've crossed them out, you then need to decide whether you're going to use sine, cos or tan. So that's where this word so, ka, toa comes in. And there's lots of different phrases and things you can use to help you remember the order. So some old hags can always hurt Tony, whatever. Yes, you can make up your own sentence to help you with that. So yeah, we use so, ka, toa. We decide whether we're going to use sine, cos or tan. Then we're going to use our formula triangles to help us solve it. So we'll use the formula triangles if we want to find a side. And then we'd use the inverses. Okay, so that's sine inverse, cos inverse, or tan inverse. Cos inverse, tan inverse. So you press shift and press those sine, cos or tan button. This is for angles. If you want to find angles, you do the inverses. Now the formula triangles, there's 3 of them. So we've got 1 for cos, 1 for sine, 1 for tan. So it just goes like this. S-O-H, so, C-A-H, ka, toa, T-O-A, like this. And you know that when things are next to each other, you multiply. When you've got one thing above the other, you divide. And then once you've used your form triangle or do the inverse, the last step is just to calculate your answer. Yeah. So the last step is normally I use the calculator to get the final answer and then round to an appropriate level of accuracy. Or they normally say 3 significant figures, something like that. Right, here's an example. Okay, so let's say this angle here is 35 degrees. The length of this side is 10 meters, and we want to work out the length of this side, which we'll call x, like that. Step number 1 is label. So opposite, whoops, that's not opposite. That's opposite. Opposite, adjacent, hypotenuse. Well, let's cross out any sides which are useless. The A is useless. There's nothing there. There's an X on the H and there's a 10 on the O. So, you know, they're useful because they've already got stuff written there. Anything that has nothing on it, we ignore, it's useless. So I've got O and H. So O and H is sine. So that means I'm going to be using the formula triangle for sine, S, O, H. Now, because I'm trying to find H, I cover up the H in the formula triangle, and that tells me that I do the opposite divided by sine. Now, when we do this, so let's do x equals opposite, which is 10, divided by sine. Now, when you press the sine button, it's going to open a bracket, and that bracket is just reminding you that you need to type in an angle. Yeah, sine, cos, and tan are useless without an angle in the brackets. So as soon as you see that open bracket sign, you type in an angle. So let's work this out. So 10 divided by sine 35. And you always close the bracket. I get 17 point, now to 2 decimal places, that'd be 17.43. So that's the length of that side x. Okay, let's try a different one. Let's have something like this. Okay, and let's say that this time I'm trying to find this angle here, and I know the length of this side. Let's do it in red. This side is 12 centimeters, and this side is 20 centimeters. Now this isn't to scale, but we want to find angle x. Step number 1, label. Adjacent A, opposite O, H, hypotenuse. Notice like the hypotenuse is still opposite the right angle. Don't let it fool you if the triangle's turned around. Yeah, you still look for that side opposite the right angle for the hypotenuse. Now which one do I cross out? H, it's useless. There's nothing there on that side. That leaves me with O and A. Okay. Now because well, let's draw the formula triangle. Okay, so TOA. Now this time I'm trying to find an angle, and the rule says that we must use the inverse. So I'm going to do tan inverse of. Now what do I do the tan inverse of? We look at the formula triangle. This is going to help us. Can you see it says opposite over adjacent? So I do the opposite number divided by the adjacent number. In this example, it's going to be 20 over 12. So the formula triangle will tell you what to put in the brackets. So we don't put an angle in the bracket this time, we put sides in the brackets. So shift and tan, press the fraction button, 20 over 12, close the brackets, and I get 59 point, if I round it, 59.04. Now this is degrees because I'm finding an angle. Just one more thing on trigonometry. Sometimes you may not straight away see a right angled triangle in a question, and it may not occur to you that's what you're going to use to help you find the lengths of sides. So let's say, for example, this is an isosceles triangle, okay, and both of these here are 70 degrees. And let's say that we know the length of the base of the triangle is 20 centimeters. And we want to work out the height of the triangle. So we want to work out this, okay, which is going to be the height. Now, notice as soon as I stick that line down the middle, I get a right angle triangle. So this part here, yeah, is a right angle triangle. So we can use our trigonometry to find that height. So for example, what that would be, if I just draw that half of it like this is still 70 degrees. This would be 10 because it's only half, and we're trying to work out this. So label, adjacent, opposite, hypotenuse. What's useless? H is useless. So it's O and A. So let's draw a right angle triangle. Now if it's O and A, it's tan, T-O-A. I want to find the opposite, so let's cover that up. That tells us tan times by the adjacent. So tan, as soon as you press tan, the bracket will open. It wants you to type in the angle. Sine, cos and tan are useless without angles. Times by the adjacent, which is 10. So that would give us tan 70 times by 10. And we get something like 27.47 to 2 decimal places. So that will be the height of the triangle. And then you could use maybe half base times height to work out the area. So the area of this would be half the base times the height, which we've worked out is 27.47, would give me the area. And if I work that out, I would get an area of 274.75. This is rounded to 2 decimal places, centimeters squared. So there's lots you can do with Pythagoras and trigonometry.